Good morning. Sorry I'm out today. A quick announcement about the exit card yesterday. Delta Math was not very equitable on the challenging factoring that some people got and the easy factoring that other people got. So I will not count that in your scores. It's been removed. But those skills are still things you need to be able to do. Another announcement, the quiz is moved to Friday. And the skills that you need to be able to do on that quiz are to identify domain of functions, which is found by finding where can you not do stuff. And those kinds of things are square root of a negative number and dividing by 0. You need to throw those x values out. So you look for domain first, and then you look for locations of holes, and that's where a factor in the numerator cancels exactly with a factor in the denominator. So that would be a removable discontinuity. And then after you find the locations of holes, any factors that are left in the denominator, those are going to be asymptotes. Any factors left in the numerator are going to be x-intercepts. Y-intercepts, there's only one. You'll find that by plugging in 0 for x, and there might not be a value at all, which, by the way, 0 is a value, but 1 divided by 0 is not. And we will also ask you about horizontal asymptotes, which, by the way, is the same thing as end behavior. So 3 rules for finding horizontal asymptotes on rational functions from Algebra 2. We said if the degrees of the function are equal, degrees are the exponents. Like in this one, the highest exponent anywhere is that 5 up here and there. The horizontal asymptote is going to be the coefficients in front of them, y equals negative 3/7. You may not leave just a number. That is not an equation of a line. You could have a function that's top heavy, which means if the degree in the numerator is bigger than the degree in the denominator, there's no horizontal asymptote. And instead, there will be some kind of slant asymptote. I just want you to know that there will be something that exists. You don't have to be able to calculate it. Just want you to know that if it's top heavy, there is not a horizontal asymptote. Instead, it will be a slant. Then the last case of these is a bottom heavy function, which is when the degree is bigger in the denominator. So here, the biggest exponent is a 4, and it's in the bottom, and that the horizontal asymptote is going to be y equals 0. So those are the 3 rules that you need to know and understand and apply to find horizontal asymptotes, and that will also tell you the end behavior. The right end behavior of this is y equals 0. The end behavior of this, well, it's going to look kind of like that on one end. Its end behavior is going to go off to positive infinity. Okay, I would like you to write these problems down in your notebook. So write down f of x equals x minus 7 times x minus 2 over x minus 2 times 4x plus 1. Are there any values that we need to exclude from the domain? Yes, because we do have divide by 0 issues. So we need to get rid of them we need to get rid of 2, and we need to get rid of -1/4. So the domain is -infinity to -1/4. We're cutting out one coordinate out, and now we're cutting out the 2, and we go to infinity. Does this function have any holes? Yes. Why? Because this factor and that factor match. So factor in the numerator matches a factor in the denominator. These are factors, not just terms. So where is this located? Where that factor equals 0. So it's the coordinate, which coordinate is with a parentheses, and then x equals 2, and the y, we're going to take the leftovers. There's an x minus 7 left over up top once we reduce, over 4x plus 1 once we reduce. How we find the y value? Where our hole was, where the x problem was, we're going to plug that in. So 2 minus 7 over 4 times 2 plus 1. So that's -5 over 9. So the coordinate, the location of the removable discontinuity, the location of the hole is 2, -5/9 and close the parentheses. Does the function have any vertical asymptotes? Yes. What are we looking at? We're looking at this leftover stuff. X minus 2 is no longer a hole, and it's no longer an intercept. It's no longer an asymptote, and it's no longer an x-intercept. Instead, it is just a hole. Those are gone. Now looking here, the factor that's remaining, that is the equation of my vertical asymptote. It's x equals -1/4. If you give me just a number, that's wrong. So x equals -1/4. All right, write this question down. Number 2, g of x equals 3x over x squared minus 3x minus 10. We need to be able to factor. Are there values excluded? Yes, because this factors to be 3x over x minus 5 and x plus 2. And when x equals 5 and when x equals -2, we have divide by 0 problems. So yes, we need to exclude -2 and -5 from our domain. So this is what our domain would look like. Do I have equations of holes? No, because I do not have a factor on the top and the bottom that match. So no factors match, top and bottom. Do we know that this has any vertical asymptotes? Yes. Why? Because there are still factors in the denominator. You should be writing this down. So what are those asymptotes? X equals 5 and x equals -2. Last question. Are there excluded values from the domain? No, because x squared plus 25 can never be 0. And there are no excluded values. So here, I would like you to write down these problems and try them. Vertical asymptotes. We're going to look at the denominator. Horizontal asymptotes, look at the lead coefficients. So I'll do this first one for you. You are expected to finish the others on your own. Also, there is a Delta Math assignment with videos related to it. Our first check, well, the domain, which we didn't ask for, but domain is all numbers except +1. Now that we've checked the domain, do I have a factor on the top and the bottom that match perfectly that would make a whole? No. So any factor remaining in the denominator, set that to 0 and solve. Vertical asymptote is x equals 1. Horizontal asymptote, the degrees match. I have an x to the first over x to the first. So the horizontal asymptote is going to be y equals the coefficients on them. 1 over 1, which is just y equals 1. REB stands for right end behavior. The right end is the end of time. As x goes to super duper infinity, it's going to go to wherever that horizontal asymptote is. And as x equals negative infinity, super left, that will also approach where that horizontal asymptote is. So your assignment for class is to watch this video, take notes, answer and submit the embedded quiz, finish these problems, and do the Delta Math assignment by tomorrow. Thank you. I will probably be back tomorrow. Bye.